Um, Hello everyone. Today we're going to be talking about K-curve methodology for inventory management. First, we need to talk about why it is important to look at the inventory management, because it will save the money for warehouse and allows you to fulfill customers' orders. Otherwise, there will be loss of orders. And then in other words, successfully control of inventory management will save operational costs. You know better about your warehouse and manage the supply chain properly. um, that's why we need to learn about this K-curve methodology. um, Moving on, we need to know the concept of K-curve methodology, where it comes from. First, we have this EOQ and Pareto principle. EOQ is short for economic order quantity. It is the definition of EOQ is that it's the ideal order quantity a company should purchase to minimize inventory costs such as holding costs, shortage costs, and order costs. And the definition of Pareto principle is this 80-20 rules, and it just basically mentioned that 80% of the consequences come from 20% of the costs. This principle, which was derived from the imbalance of the land ownership in Italy, is commonly used to illustrate the notion that not things are equal and the mineral owns the majority. Then we have this formula of economic order quantity. It equals to square root of 2 times demand in unit times order costs divided by holding costs. And then let's have a look at the diagram of this. So the purpose of figuring out economic order quantity is to know when to order and how much you need to order it. If we look at the diagram here, it just basically means balancing the costs related to the number of order being placed against the costs related to the size of the order being placed. And when the two curve meets, or when the two curve being balanced, you can see where the total cost is at where the minimal total cost is. And also at this exact point, you'll be able to get this optional order quantity. However, despite this EOQ is being useful, there are limitations. For example, the next page, it shows that the EOQ is relying cost of ordering and the cost of holding inventory to be constant, which is very difficult to calculate, and immediate availability of product is required with the supplier, which is also very hard to do in a real life situation. And this also formula also based on one product business. Again, it's very hard to find in real life that you only have one product in a business. Also, this assumption is based on constant demands, which you require over 12 months, and constant unit costs, ordering cost, inventory cost, and constant lead time. Again, this is also not practical because of, say for example, in real life there's some discount involved, and there are fluctuations in real life as well. And moving on, we have this Pareto principle, which also understand as ABC analysis. So if we look at this diagram, it shows that ABC analysis classified items into three groups: category A, category B, and category C. At the bottom there is a cumulative percentage of inventory, and that's on the X, and then on the Y it shows the accumulated annual consumption value. So in brief, ABC analysis just categorize all the inventory into three groups. Also, the group A is the most valuable one. However, in real life, it only have like around 20% of the total inventory, but it has up to 80% of this value in it. And then group B plus group C has another 80% of value in it. And then here's the example of ABC classes. For example, A item, 20% of the item counts for 70% of the annual consumption value of the item, and the B item is 30% of the item accounts for 25% of annual consumption value of the item, and then the C item is 50% of the item accounts for only 5% of the annual consumption value of the item. But even for the ABC analysis, there are limitations. First of all, it's the three categories. So it can allow business to classify the inventory into more groups, only limited to three groups. And then the boundary of A, B group or B, C group is chosen by the manager's preference. So again, it's not ideal. And then the fixed percentage into each class, regardless of the nature of each item. The moving on, there will be like based on the assumption of constant demand over 12 months, just like the EOQ. There are some flaws, and then this only focuses on managing the few important and replenish those with low value, which leads to like unconnected decisions. They just neglect the less valuable item. But as you can tell, in the group C, although they count 5% of the annual consumption value, but it has over 50% of the inventory are classified as group C. But if you only focus on group A, you're gonna be waste 50% of the space, not using them as much. That's why it's not ideal to neglect those less valuable items. Then we have this K-curve. K-curve is introduced since 1990s by Shah Butcher to address these EOQ flaws. So it's based on EOQ model, and then it is set to solve what does it cost to place an order, and the formula as well, which later I'm going to explain more in a brief, is to cost 2C, which is cost of ordering divided by inventory holding rates. If we have this next page, which shows the generate K-curve 3 steps. The first step is expressing EOQ as EOP, which stands for economic order points. It again is substitute K equals 2c divided by I, and we can show a clear picture on the next page. Let D to be the demand quantity, C become the cost of ordering, P is unit costs, I to be the inventory holding rate. So again, we have shown this EOQ formula is square root of 2 times demand quantity times cost of ordering divided by unit cost times inventory holding rate. But if we want to find a common factor of K, we can substitute that 2 times cost of ordering divided by inventory holding rate, and let that to be the common factor K, and then we can have a simplified EOQ, which comes down to square root of K times demand quantity divided by unit costs. From there, we can find out the economic order period. That's just EOQ divided by demand quantity, and then this is to have this 0.02 years. In other words, every 0.02 years we have to order 20 economic order quantity. However, it is still in years, therefore we have the following steps which helps to express this into days, economic order period into days. So what we can do is we can use D times P, which is demand quantity times unit costs, because it's annual spend. If we times this amount with working days, there's only 250 days. Let's just say 250 days is a working day in a year. So what we can do is use this K factor divided by the new annual spend, which is D times P, square root of that times 250 working days, which gives us 5 days. Then we use that to calculate the average inventory. Is 0.5 times this EOP times this annual spend divided by working days. The reason there's 0.5 is because it's average inventory, because it's like the highest inventory plus the average of highest inventory plus lowest inventory divided by 2. So that's why there's a 0.5 at the front. Then we have this number of deliveries. In other words, there are number of orders. So it's working days divided by EOP, and then that's 250 working days divided by 5. So we have this. So in other words, is if we have to order every 5 days, in a year, we are going to order 50 times. Now we're moving on to Excel to see how we're gonna do this in Excel. Here we have this these 200 items. We have the number counts on all the way to the left, and then part numbers, they are not as important, that we're not going to use that for any calculations. And then we have this annual usage or demand, and then the cost per part, and on the top left we have this common K, and then down there are the total working days in a year. So the first step that we need to do is to calculate this annual spend value. It is calculated by multiply the annual usage times cost per part, and then you just simply drag this plus sign all the way down to the bottom, so these 200 items are all being calculated using the same formula. And then we have this EOQ, as it's shown in this PowerPoint slide. It shows the simplified the EOQ formula is square root of K times demand quantity divided by unit costs. That's why we have this formula put in the Excel, as it's shown over the Excel, and we do the same. Use this plus sign and cross it all the way, drag it all the way down, so these 200 items are all being calculated using the same formula. The next step is converting this EOQ into EOP in days. Again, in the PowerPoint slide, it shows that is using this formula is total working days times square root of common factor K divided by annual spending. So we're gonna be using this formula into our Excel sheet thing. So the formula is shown in this Excel as well. As you can see, we have this 250 total working days, and we're gonna be times square root of K. We have K already, and then we have already calculated this annual spending value. So just using this to calculate everything as it is shown here, and then you drag all the way down to make sure all the 200 items being calculated the same way. And if you look closer, you'll be able to see the very interesting common factor, which is when annual spending value increase, the EOP decrease. And if you just look at the first two examples, when the annual spending value increase from 0 to 210, the EOP decreased from 32,000 to 94 days. And if the annual spend value increased from 210 to 54,000, the EOP decreased from 94 to 5 days. And then moving on to the next step is creating a bridge between EOP and the Pareto. Similarly, like on the Pareto principle, it classifies items into 3 groups. Instead of doing that, we're gonna be using this table classic value for EOP. It is based on the class limit. Here, let me demonstrate how I come up with the table. We have this value class from 1 to 7, and then the cycle days. For cycle days, we just run up this EOP in days. We run it up because as you can see, there's a lot of like 5.84 or 6.2 those days. Like we simply just run them up to these 5 days, 10 days, 20 days, 40 days, and 80 days, is 160 days. And the question is why there's no 320 days, because in a year there's only 250 working days. So if you multiply 160 times 2, that's 320 days. That will be impossible. That's not practical in real life, since there's only 250 working days. The class limit is calculated using the formula that is shown here. Again, you make sure to drag all the way down to make sure every category, every class has been calculated using the same way. And the class limit is the most economical points to switch from class 1 with 5 cycle days to class 2 with 10 cycling days. A quick example for class value is that if we look at this annual spending value, if it is over 37,500, then it will be classified as value class 1. If it is between 37,500 to 9,375, that will be classic as value class 2, and so on and so forth for the following ones. Therefore, we apply this to all these 200 items. Now we have classified every item into their value class, and then we need to match the cycle days with value class. You can see the formula by looking at here. Moving on, we have the next page, which is number of orders. We can again look back at this the PowerPoint slides. At the number 8 here, we have the number of deliveries, which also means number of orders. So it's total working days divided by EOP. And then the average inventory formula as well, just right above. It's just 0.5 times EOP times annual spend divided by total working days. So the formula, it will be just like this, just on top here, and then just make sure to calculate every single column. Just copy and drag all the way down. That's for number of orders. After calculating both, we need to drag this all the way down. Make sure to calculate the total number of orders and total average inventory as well. The next step is we're gonna be vary the constant K from 1 to 100. As you can see right now, it is set to be constant K 30. And then what I can do is I can just change this number, and then the whole value will be changed. So for example, if I change this to number 1, right, so as you can see, the class limit has changed, and then this number of orders and average inventory also changed. So again, we're gonna take the total number of number of orders and the average inventory, and gonna use that figure. And then the K that I choose for this K equals 1, equals to 5, equals 10, equals 20, and since we already have this as 30, and then we have 40, 50, 60, 80, and the last one is k equals 100. So after finishing like calculating total number of those number of orders and total number of average inventory, from those k variance, we need to open up another one to put everything in this one page. Another interesting factor is that when the number of order decrease, the average inventory increased. That makes sense because when we don't have enough inventory, then we need to increase number of orders because we don't have much in stock to back it up, so we need to order more. And if we just select the whole table and use scatter to create a chat, and this will be what it looks like, and this is what we call K curve, with number of orders being X and average inventory being Y, and then the value of K along the way. We are using K curve to answer question like how many deliveries can one cope with, which is more convenient to answer the question like what does it cost to place an order. So in summary, the number of order can be said to be the capability of the business to process order in the work area. If we are able to take decision about the number of deliveries we can cope with by drawing the vertical line and intersecting the curve, we can arrive the optimal inventory for our capability to process the order. The decision will help us to arrive at the appropriate batch size for each part. So if we look at the curve right now, for example, if we are given a target of 5,000 inventory, that we know if we draw a line from 50,000 inventory, if we draw a line from 50,000 and then the intersector and draw another vertical line down there, you'll be able to see the number will reach around 32,000 hundreds of number of orders. So another example will be if we draw a line at 45,000 average inventory, and then it will meet at the K20, and then if we draw a vertical line down there, the number of orders will roughly around 3,800, and we know that will be the optimal inventory for our capability to process the order. So at the end, I want to go back to the PowerPoint slides to talk about why we're using K-curve. Again, like the example that was shown, it is to make a rational decision. This helps to solve the weakness of EOQ. It also helps to determine the number of batches or the target inventory level. So no need for holding costs because we already have the optimal one. This also helps to solve this ABC analysis weakness because the value class table allows more classes rather than just ABC 3 classes, and then the allocate order size is based on the economic order principle. It's not just everything being smashed together. And this can compare the cost of increasing the business capabilities to meet the proposed inventory benefit, and then it's easier to understand the benefit of inventory reduction by understanding costs of the increasing capability prior to going ahead with the inventory reduction. And this will be the end of this K-curve methodology of inventory management. Thank you.